All right, welcome back. So we're going to be talking about trig identities, and we'll see how far we can get. So here we go. We're given cosine x times quantity 1 plus tangent squared x is equal to secant. So let's see here. Each statement must be based on a rule chosen. See detailed description of the rule. You can select more information and then figure out what's going on here. Okay, so how do I want to think about doing this? Let's go ahead and pull this thing up. Okay, so I've got cosine x, sine x. We've got 1 plus tangent squared x is equal to secant x. Okay, so I'm going to go back and remember this and say sine squared plus cosine squared is equal to 1. If I divide everybody by cosine squared, then we're going to get sine over cosine, which is tangent squared. Cosine over cosine is 1, and that is equal to secant squared x. So my first thought here is to use a Pythagorean identity. So we have cosine x times 1 plus tangent squared is going to be secant squared x. Okay. And then say, oh, wait, cosine is really 1 over secant. Okay, so this is 1 over secant x. This is a reciprocal rule times secant squared x. And then what's going to happen next is an algebra step where we take secant squared over secant, and this is just going to be equal to secant x, and that's what we were supposed to prove. Okay, so we're going to go ahead and say, let's write down this. So we have this is going to be cosine x, and I can say cosine x times secant x. So cosine x times secant squared x. And the rule I'm going to pick is I want a Pythagorean. Okay, this is the Pythagorean rule. Okay, so we'll say validate. This line is incorrect. Oh, because I accidentally typed in a 3. I meant to type in a 2. Validate. I've got cosine times secant squared. 1 plus tangent squared is in fact secant squared. We're not going to change anything with that. We're going to pick Pythagorean. It didn't like, for some reason, it just didn't like it. Okay. And I'm not really sure why it didn't like it. It just didn't like it. Oh, okay, now it went. So I messed with the parentheses for a little bit until it decided to accept it. So now I'm going to say this is going to be 1 over secant. So this is 1 over secant x. Okay, and part of the reason I don't mind doing this for this section especially is because in the past, students have told me that this has been an incredibly frustrating experience, and I can appreciate that. This has been a reciprocal identity, I hope. So let's validate that. Okay, it seemed to like it. And then we're going to say this is equal to secant x. And we're going to call that a algebraic rule. Okay, and say validate. Your proof is complete. Hooray! So hopefully that gives you a little bit of an idea of the kind of thing that they're looking for. Okay, check. It's not even right yet. Now it's right. Okay, we didn't get the green mark until we got it right. So expect a lot of false starts. Expect sometimes you're going to skip over some steps and it's not going to like it. So you're going to have to retrace it and you're going to have to go through and do this. And this is just to teach you the fact that when you do this, you have to justify each and every one of your steps. And you could look at that and say, well, yes, it's correct. Like, well, no, not really. You have to show me why you think it's correct. You're developing your logic base here. when you get hired as an engineer, it's like, yes, you'll be able to say, yes, this is going to be obvious or easy or whatever. And I would caution you not to do that. But the idea is your boss may have taken trig, but this may have been the worst part of trig for them. Okay. So it's your job to convince them that you're right, and you have to lay out your argument in a way that they can follow it. Okay, so here we have tan x times, okay, tan x over cotangent x times cosine x over sine x. Now I don't really know what they want us to do with this. I'm going to go ahead and say something like this is going to be tan x over cotangent x. What's cosine over sine? That's a cotangent x. Okay, so I'm going to go ahead and cancel these out. Okay, and that's just going to be equal to tangent x. Now, is that what they want? I have no idea if that's what they want. Oh, wait, yes it is. They want to show it's equal to tangent of x. Okay, so let's see what we have here. My first thought was just to take cosine over sine. So we're going to say this is going to be tan x, and over, oops, I was afraid I was going to do that. So, nope. I don't want a fraction. The first thing I want tan x over cotangent x. I didn't like that at all. We have to go over here. We'll say cotangent x. Okay. And then next we'll say sine x over cosine x, or cosine x over sine x. That's also a cotangent x. Okay. And our rule, what did we do? We decided that was going to be a quotient rule because cosine over sine, that was a quotient. Okay, and we'll say validate. And then we'll select a rule. We'll take an algebraic rule. We'll say cotangent over cotangent is equal to 1. So we'll say this is tangent x. And the rule that we're going to use is algebraic. When in doubt, pick algebra. Okay, and we'll say validate. Proof is complete. We'll check it because we're not right yet. Okay, and now we get the green check mark and we can move on. Okay, so the one thing actually that we do like about Alex on this one is that it will let you run around in circles until you die of old age or by a group, because that's how real trig identities work. Is that you are allowed to run yourself around in circles and not really get anywhere. Okay, that's just part of the experience. I shouldn't have to do it that way. It's a rite of passage. Everybody who does trig identities has gone around in circles at least once while they're doing this. Okay, you are not alone. This has happened to everybody. This has happened to me. And I'm not even, when I learned these, I thought they were fun and I kind of liked them. But I can't even say that I was the best in my class with these. I wasn't. Okay. So here we have show that 1 over 1 plus sine A plus 1 over 1 minus sine A is equal to 2 secant squared A. Okay, well, let's see here. We have two fractions. When you have two fractions, I'd kind of like to think that getting a common denominator might be the way to go here. Okay, so we've got 1 over 1 plus sine A. I might even call that an alpha. Okay, plus 1 over 1 minus sine A. Well, let's see what we got here. Why don't we cross multiply here, get common denominators? So why don't I do something like this? And I say 1 plus sine A over 1 plus sine A. And then over here, we'll say 1 minus sine A. And then over here, we'll do 1 minus sine A. Okay, so all I'm doing is multiplying each side of these by 1. They are probably not going to like this. Okay, so my my step, because I'm going to have to write this out. Okay, this is going to be 1 minus sine A all over, and let's do 1 plus sine A, 1 minus sine A. Let's see if they can let us get away with that, or how much they let us get away with. And on the other term, we have 1 plus sine A, and then on the bottom, we're going to have 1 plus sine A, okay, and then times 1 minus sine A. Now let's hope that that works out. Okay, so let's check. We have, what do we have? We have 1 minus sine A, minus sine A. Oh, you know what? We aren't going to like this because I need to put the fraction in first. Okay, and then we're just going to beat them to the punch, plus another fraction. Okay, now we're going to have, what do we have here? We have 1 minus sine A on the top here, 1 minus sine A. On the bottom, we have parentheses, 1 minus sine A. Say, why are you doing it this way? Like, they don't like it when you take too many steps at once. And since the computer is our friend, we're going to obey. Okay, and then here we have 1 minus sine, oops, 1 minus, no, we're not. We're going to put it in a fraction. 1 minus sine A. And on the bottom, we're going to have 1 minus sine A. And there, I think, yeah. And then 1 plus sine A. You'll see, when you do this yourselves, you'll say, well, why couldn't you just combine them? Like, I probably could have, but they ain't gonna like it. Did I multiply by 1 plus or 1 minus here? I think I multiplied by 1 plus, didn't I? Let's do that. Okay, this was 1 plus times 1 minus. This was just 1, and then we multiply by 1 minus. Okay. Yeah, I think that's what we are. Okay. So roll, what did we do? We did a lot of, I would say we did a lot of algebra. Okay, so I would say that's an algebra step here. Right there. Okay, we'll validate. And then, see, that's the other thing you need. Now that we have a common denominator, we can add these. We have 1 plus, that'll be 2. Okay, actually, let's put the fraction in. We'll have 2 over. Now, let's see. Can I multiply 1 plus sine A, 1 minus sine A? Let's see if they'll let us do this. So we'll say 1 minus sine squared A. And let's see if they actually let us get away with that. Okay. What our rule is, when in doubt, we use algebra. Okay, because that's what we did, is we just added 2 fractions. All right. And now we can go back here. We can say, okay, well, now we have 2, right? Because 1 plus 1 will be 2. The sine A and minus sine A cancel. So we have 2 over. And now I've got 1 minus sine squared A. Okay, so remember, sine squared plus cosine squared is equal to 1. Okay, cosine squared is equal to 1 minus sine squared. Okay, all we did was take the sine squared to the other side. So here we're going to have 2, oops, I want to go back over here. So we're going to say, oh, let's put the fraction in. We want 2 over, and then we have cosine squared A. All right. We'll say validate, and we'll see if we take that. That's an algebra step, because all we did was we just plot that out. Okay, so we'll say it's an algebra step. And again, when in doubt, pick algebra. That's probably your best bet. This line is incorrect. Oh, because it's not algebra, it was a Pythagorean step. See how picky they're going to get. Now they're okay. Okay, and now it's reciprocal because we got to put, notice the top is, we have secant squared up here. So now we're going to go ahead and say we got 2 secant squared A. Okay, what rule was that? That was a reciprocal rule. Maybe a quotient. I think that's reciprocal. Let's say reciprocal. Validate. Your proof is complete. Not done yet, but check. Okay, and now we got the little green check mark, and now they're happy. Okay, so yeah, that's just kind of an example of what's going on when we do this. And let's see, how many do we have left here for ourselves? Okay, that's 10. I think we I think we got one more in a second. Okay, let's go and continue. Okay. Oh no. We'll go with one more. Okay. I'll go with one more because I know there's at least 2 more, so we might hold this off. So I know that these take a while, and there's gonna be a time to think about this. Okay, so let me go ahead and shut this off, and we'll start with a new one. And again, if you're worried that if you're having trouble, like because you haven't gotten quite the right validation yet, don't beat yourself up over it. This happens to everybody when they get to this section. These are delightful. So good luck with doing this. And again, try not to do too many steps at one time. Try to keep it simple so that the computer can follow along. Pretend your boss who hasn't done math in 30 years needs you to prove this to them. Okay, and we'll go with that.